Hi, today I'm going to talk about ionic bonding, one of the small topic of chapter 4 in IB chemistry. So for the defined ionic bonding is an electrostatic attraction between opposite charge ions. So for example, in here we have like Na, which is plus, I have a plus, and Cl, which have a minus, and together they make an ionic bonding because we have opposite charge ions. So they occur between two elements with a 1.8, not 1, larger than 1.8 in terms of like electronegativity, and they are they are composed of a non-metal and non-metal ions. Okay, let me give you guys some example. For example, here we have lithium, which is a metal and have a plus charge, and we have fluoride, which is a non-metal atom and have a minus charge. The fluoride have 4 in terms of electronegativity, and lithium have like 1, which when we minus together they have a 3 in terms of different in the electronegativity, which say that like they are ionic bonding. They are an ionic compound, and also they follow the octet rule. So octet rule is a rules that like an atom prefer to have like their outer cell, which is like the circle in like the most like the place of the outside of like the nucleus as far as they can, and so that they have a stable charge, I guess. And for example, here we have sodium and chloride. Sodium in the outer cell they have a plus charge and they have 1 electron outside. However, the octet rule they prefer 8, so they will try to lose it electron by giving it to the chloride one. In here chloride we have in outer cell we have like 7 of them, 4, 5, 6, 7, which give them a minus charge, and they are 1 electron away from like the octet rule. Because of that, they take the electron from like the sodium, they receive it and then get the electron, which make the outer cell a electron. Yeah, and that's basically the octet rule. Yeah. So next up is the lattice structure of the ionic compound. So just imagine it's like a 3D net, like shape, yeah. And let me give you guys some compound. We have like sodium chloride again, which is a salt, and we have, yeah. And let's assume that like the black is like the chloride and the white is like the sodium, and here we can see that like the sodium gets surrounded by 4 chloride, 1, 2, 3, 4, yeah, and it's repeated. Also the same for this chloride, where like it's for the chloride it gets surrounded by other sodium compound, yeah, and together they form like yeah, a curved structure. Not really a curve, like can like have like a lot of shape, yeah, but like just think it's like a net cell, and you call it a lattice structure. Mm. Next up, they also have a high melting and boiling point. The reason for this is because yeah, the reason for this is because first of all because because the five of them is they have an electrostatic force between like the charged ion. So because but like the bond between them is very strong and it's very hard to break. Therefore, it requires a lot of heat and energy in order to break them. Therefore, they have a high melting and boiling point. And because of that, most of the time the ionic compound in like our normal room temperature, about like 27 Celsius degree to yeah, about, yeah, 27 Celsius degree. They are all in solid structure. Yeah, and the strong of like the ionic bonding of a compound depends on like the ionic charge and the radius of them. And yeah, so the higher, for example, like let's not do that. Let's not do cosmic. Yeah, I have this slide. Yeah. Okay. For example, we have magnesium, and we have chloride, and we compare them to Na, and Cl. This one, oh no, not, I forgot the charge. Yeah, not the charge, but double chloride. This one will be stronger than this one because this one have 2 plus, while this one I have like one ionic charge plus. Yeah, so that's mean like the ionic bonding of this thing will be higher, and therefore like the melting point and boiling point will be higher compared to like the sodium chloride. Okay, next up for the radius, say we have there's some example. For example, we have sodium and fluoride and sodium and chloride. Yeah. They both have like the same number of sodium, so I will not care about its radius anymore. But like for the fluoride have a smaller radius, down the radius than the chloride one, and this make it stronger because like like when like the radius is smaller. Let me give you some. Okay, so for example, we have this circle. Let's think this like the sodium fluoride, and we have like the sodium fluoride. This one will be bigger because they have a larger ionic radius. So when they hit come, like because it has a bigger ionic radius, it will receive more heat as it has more surface area. While this one, because it have like less surface area, it will receive less heat, and therefore like the bonding between them is harder to break. Therefore, leads to the higher melting point and also maintenance one. Yeah, and I also forgot that like because their ionic radius is smaller. Let's think. Let me remember like the. Okay, so for the fluoride, you have like 9 electron, right? And then for this one, have 17 electron. So this means like this one have like less like cell. The cell is the other one, and therefore like the nucleus charge against the sodium will be stronger, while for the chloride one it will be like weaker because like it take the electron in the way out of cell much more than the fluoride one. And next up, one another physical property of the ionic compound is that they have a very low volatility. Volatility here is like how easy like the compound evaporate at like the normal temperature. Okay, for example, you can say like if you left your water out in like some place, not outside of the sun, but like just at in your room, and after time you see that like the water level in that cup drop, and yeah, then that's for that volatility evaporate at normal temperature. And also for solubility, some of the ionic compound can dissolve in water, but like some cannot. Like they didn't explain it during the ionic chemistry, so I will not explain this one. I was just said that some can, but some cannot. And if they can dissolve in water, this process is called hydration. Okay, so um, for example, you know that like the ionic compound have a lattice structure, right? And here's the lattice structure of the sodium chloride, and because like the Na plus have a plus charge and it's Cl plus, and Cl have a minus charge, and so and also for the water, because they have a different electronegativity for each atom, as you can see here. This the oxygen has a higher like electronegativity, so they tend to like attract more electron, while like the hydrogen attract less. Therefore, like therefore because it's polar, it will go look for like the not this another plus ion from the sodium. So have one. Remember that the sodium have like it's outside, it have one like extra electron that it want to lose. So like the hydrogen will try to like not really attract, but like actually attract, not bond to like the sodium, but like attract to it, as we can see in this image over here. It attract like the sodium and it drag like the sodium away from the lattice structure, which led to this like the solubility of like sodium chloride. And the same for chloride too, because the chloride have like the minus charge. The hydrogen over here will try to like drag like the chloride ions out of like the lattice structure, and this they just detach like the sodium and the chloride away from like the lattice structure, and from there they dissolve in water. And this process called hydration. And there's another physical property of an ionic compound is like they doesn't conduct electricity at a solid state. The reason for it is because, as you remember, the ionic compound has an lattice structure. Uh, yeah, in here we can see, yeah, they have an ionic because like the lattice structure is like fixed and they cannot move. Therefore, the electron between them cannot move, and therefore they cannot like conduct electricity. However, when they melted, which will destroy the lattice structure, and here we can see this like the melted form. Yeah, like the ions detach from each other, and therefore like the electron can move through it for it. Yeah, and lead to like the electricity conduct. And it's also the same for like the dissolved one. I mean like the hydration of like the sodium chloride. Um, it can, yeah, because like the NaO here is like detached away from like the chloride. They're not sticking together, so that the electron can move through it to them, and this allow them to have like the electrical conductivity. Yeah. Also, the last physical property that like the ionic compound have is they are brittle, very very brittle. They can easily break into like multiple shape, and the reason for it is because like when we apply a force, okay, I have an animation. Again, remember like the ionic compound has a lattice structure, right? So when a force applied to them, and here we see the hammer in here, it will if we push for, okay, let's say if we push the side down, and as we can see here, when like this pot move down, it will like meet with like an opposite, will meet like with the atom with the same charge. And as you know, like if the same charge meet each other, it will create like a repulsion and push them away from each other. We can see some example here, like I think you guys know like the magnetic couple or something. We have a plus charge and minus charge here, and if they stay like, if another magnetic curve have like the different charge, they will like attract to each other. But like if they have a different charge, for example plus and plus here, they will push away from each other. Yeah, and that thing also work the same for the brittle and ionic compound.